Hey Kadi, hey Samit. This is a brief video demo that goes together with the write-up that I shared about a task for the HuBMAP stage 2 registration. So I was supposed to share 5 tissue block data sets, well, really 6, including the default, with 1%, 2%, 5%, 10%, and 50% noise applied to all sphere positions of the tissue block, all in 3D, obviously. Apply no noise to kidney block, stays the same for all registrations. Use average distance across all spheres in kidney block as 100%. So first I want to demo here what I built. So at first glance it's going to look very similar to what we've seen so far. We have the kidney block and we have the tissue block here. And now I have these buttons up here and I've set them up such that they apply, well, there's a bunch of stuff that happens under the hood, but once I click one of these buttons, you're going to see those spheres here move. So now I'm going to apply 1% noise. Here we go. I click again, get some more noise. And of course, all of this is within a specific set of boundaries. I'm going to zoom in a little more here. Another thing you're going to notice is that this bounding box of the tissue block actually moves along with the spheres, so that it always encapsulates all of the spheres. Now 2% is obviously a little more, 5%, we'll see more, 10%, and then 50% is obviously a lot bigger. And then I can reset to 0 and I have the exact same positions as I have in the beginning. By the way, that actually happens whenever I click any of these buttons. The first thing that happens, of course it happens too fast for us to notice, and it's actually not even rendered, is that all of the spheres are automatically reset to this position and then we apply the new noise. So that will be obvious. I always have the same baseline. So I want to just very briefly talk about how I implemented this in code, and I really just have to look at one function. Here, apply noise. This is C#, by the way. So here what I do is I loop through all of the cells in my cells generic list. My cells list, really what that means is this is a list of all of the sphere objects in the tissue block, and I loop through them. And then I compute a translate vector, which is going to be new, of course, every time we call this function. That consists of 3 factors. A random position on a unit sphere, so that's some Unity magic. Really what that means is if you have a sphere with radius 1, we choose a random spot on that sphere. This is just very neat because it takes a lot of work off of our hands, and it just gives us a random location on a sphere surrounding an object. And then we multiply that with the mean distance across all of the cells, and we compute that a little bit higher up. Then we multiply that by the noise level. So if my noise level is 0%, the translate vector is 0, so we do not move the cell. Okay. If my noise level is 10%, then this is 0.1, so we move towards this the location of the unit sphere 10% of the mean distance. So that's how I implemented this requirement. All right. And lastly, I would like to show you what the exported data looks like. So here we have, this is the default as far as I remember. And yeah, I've shared all of these with Samit. Obviously the data sets are getting pretty large. But yeah, that should give you a pretty good idea. Thank you very much.